for that. Okay, we're recording now, and people are logging in. Please turn your video on. We want to see your pretty faces. Even you, Stefano. Ah, good to see you.
Hello, good to see you guys.
How you doing?
Good, good.
Great, great, great. All right. So usually we would say let's wait a few minutes for people to get here, but not today. So we're just going to get going. And wow, we already got 14 people on, and I think they'll keep coming. So anyway, welcome everybody, and thanks for joining us. We saw several of you in December at our technical working group for the Innovation Information Initiative, which I can't say without concentrating. I'm going to call it I3. So it's great to see so many of you at the I3 working group in December. One thing that happened, and I3 has been evolving. So at the beginning, we were all about trying to build open data sets like Gaetan's iProduct, like Reliance on Science. And then we also said, hey, we should celebrate. It's not just a couple of us. It's like celebrate all the other open data efforts that are underway, which led to the working groups. And suddenly there were so many that we couldn't keep track of them. So we started the I3 Index to catalog and link to different data sets that are out there. But then Dror, who's co-hosting this, I'm going to hand off soon, said, wait a second, now there's like links to 500 websites, and then I have to download and I have to merge these together. Shouldn't we just have a one-stop shop, a data repository where all these things are hosted, where we can see, what years they cover, what countries they cover? And that was the i3 BigQuery workspace, which we, and especially the drawer part of we, put together right before the technical working group. So that's been out there. We'll post the link. We'll also post the Google group that you can join to get updates on that. But that's a new thing for a lot of us, especially dinosaurs like me who are still coding in Perl. Yes, Perl, the Latin of computer science. And so that's what led us to today's first I3 upskilling session, which is how do you use BigQuery? How do you navigate it? What's it good for? What are the limitations? How do you avoid Bitcoin miners commandeering your account? Not that that happened to me last year. And for that, we have brought in an expert. Now, you might think his name is Roger, but it's actually Roger Masclans. And he's a PhD candidate at Duke. And he studies commercialization, but not only is he studying it, he has already put out an amazing open data set predicting the commercializability of academic papers. So super excited. And by the way, this is also cool because when we started I3, we thought the only people who would do open data were kind of dinosaurs who are post tenure, who can afford to do stuff. No. And now it's the new generation, like Dror, like Roger, like doing this early, which is so fantastic. So speaking of getting rid of dinosaurs, I'm going to go on mute and hand it off to Dror and Roger. If you have questions, please put them in the chat. We're going to try to batch those up, and then Dror will sort through. We'll see what we can address. We'll probably go a little bit past noon, so if you need to go, we are recording the whole session, which we'll send out and you can share with people. And with that, let me hand it off.
Should I start? Okay, good. So thank you very much. Thanks everybody for joining. Thank you, Matt. Thank you, Dror, for organizing this session and for inviting me to lead it. I'm really excited to be here because I really think and truly believe that working in the cloud with tools like BigQuery is kind of like a game changer for doing research, and it's a super tool, okay, that's going to streamline all the workflows that you work with when working in data. Not only is gonna make you faster in terms of like computing time, right? That I will show you some examples today, and processing data will be like 10x or 100x faster, right? But also in terms of your time and your mental energy, if you work in the cloud with solutions like this one, now you don't have to deal as much with like writing crazy code, dealing with errors, missing packages, and running out of memory all the time, and computer crashing, and so on and so forth, right? So I think this is a super tool, and I think this is a great initiative that Matt and Dror put together. So that is fantastic. Now, for today's session, this is going to be hands-on. Okay, I have no slides. I'm going to assume that the folks that joined are not familiar at all with BigQuery, and that you may not be familiar with SQL, which is the language that we use in BigQuery to deal with the data. And what I'm going to do is just work directly, share my screen, and be working directly on BigQuery so that you can see kind of like the fundamentals in action and get a practical feel for how it works. Okay? And so two main goals, therefore. Goal number one, for you to get familiar with the UX of Google Cloud and BigQuery, understanding how to navigate, and the main parts of working in BigQuery, which are uploading data, manipulating data or accessing data if it's already in there, such as like the NVR i3 data, okay? Manipulating this data via these queries, and then downloading this data for further analysis, right? So for example, in my case, usually I try to do as much as I can in the cloud, and when this is ready to analyze, then I download an efficient file for processing in data, for example, right? So I'll show you how to do that, okay? Goal number two is give you a basic understanding of SQL. But just a disclaimer here, learning SQL takes some time as any language, and I'm not expecting, if you are not familiar with SQL, for you to follow everything I do in every query. What I want to do is give you an overview, okay? Now, writing code in SQL is easy. You are all great researchers, very familiar with handling data, okay? So you can do it on your own. There are plenty of resources to learn SQL. And today, like LLMs do a perfect work. So you just type in natural language what you want to do with your data, which you already know because you're already people very familiar in handling data. You type it to your favorite LLM, whatever, ChatGPT, Claude, you're going to get almost perfect queries, if not perfect queries, that then you can copy, paste, and run. And boom, you will get the results and you will see how magnific this is. Okay? Hopefully this approach that we kind of like designed for today will help you the most in getting up and running quickly, will lower the entry costs for you all, okay? And will save you the most time moving forward. Yes? Sounds good? So can I start? Awesome. Great. Thank you, Matt, to see someone like really interacting with me. So just let me share my screen. I'll start sharing my screen. And so, good. I guess you all can see my screen. Let me just like organize my other screen. See that? Okay, fantastic. So I'm going to start by showing how to set up an account. Okay, easiest way, you type in your search engine, Google Cloud Services. You go to Google Cloud, you end up in this landing page. Your goal is to go to the console, okay? And now BigQuery is a product. It is one out of 100 products that are available under Google Cloud, okay? So when you land to your like console in Google Cloud, this is not BigQuery yet. This is the Google Cloud homepage, okay? The first thing you're gonna see usually is not this page, but is a page that will ask you to register, okay? To input your credit card to be able to use Google Cloud. Now, the beauty of Google Cloud is first, you get free credit, all right? So to access this free credit and start running queries and hosting a little bit of data, you will have to input your credit card. But the beauty is this is not like Netflix or any other kind of subscription service. Once your free credits are depleted, you're not going to be charged, which is nice, okay? You should manually upgrade your account. So you will be always in control of all the costs that you are going to be facing on BigQuery. So, and I'll talk about that briefly later, but this is usually under control, and BigQuery or Google Cloud has like a perfect way to manage cost, okay? Now, the idea here is like, you will see a pop-up here, and this is an account I created for the purpose of this session today, but you will see here a pop-up that says like, activate your free credits. I encourage you to do that. Again, I don't want to be responsible for any charge you may incur, but I encourage you to do that. Okay, put your credit card, activate these free credits, and then you can start working on any service actually under Google Cloud. Okay, so that's first step. I'm gonna skip. I did that yesterday when I was preparing this session, but very simple. Now, once you have an account activated, and actually, by the way, you don't even need to activate it to kind of start messing with it, but let's assume once you have an account activated, okay, let me do just take two quick notes here on the homepage on Google Cloud Services. The first thing is Google Cloud is very useful because it's managed under projects, okay? So the first thing you will have to do is you will have to come under like here at the top left. I hope you can also, do you see my screen well? Do you want me to zoom in a little bit maybe? Maybe this is better. So you will, Google Cloud works at a project level. And this is very helpful because we often work on different projects, right? As researchers, and I may be working in a project with Matt and Dror, and then I may be working in another project with Nicola. And these projects are not only involving different data, but ones are built to the Sloan Foundation, and the other one is built to Duke Fuqua, right? So all these particularities you can manage on BigQuery, okay? Sorry, on Google Cloud. So the first thing you have to do when you have an account is to come here, and usually you won't see any project. You can say create a new project. This has no costs. You type the name of the project here that you want to see, and this name can be any name you want. You can edit the unique name, the project ID. This is going to be a unique identifier for this project. You can edit this if you want, and then you just create this project, okay? And I'm just creating this project right now. Now, once you have this project created, now moving forward, you will have this here as a potential project, okay? Now it's in here, and you select the project you want to work with, okay? So for today, I'm going to work on this intro to BigQuery project I created. Good. So first thing, we work at the project level. Now, every time I go and launch a product available on Google Cloud, can be BigQuery, but can be like the storage service. It can be for machine learning, okay? These products are going to be launched under a project. I can change this project. This header is always available. You'll see that. Now, two brief notes. You can access the billing here on this panel, and you can set billing accounts, as I was saying, and you can link billing accounts to projects, and you can have two projects linked. This is a many-to-many, right? You can have two projects linked to one billing account, or you can have one project linked to many billing accounts, and transparency is great. For today, I'm not going to get into billing. This usually is not very complicated, but I want you just to be aware of these like whole possibilities we have in terms of billing, which usually we have to deal with, okay? The other nice feature is that any cost that we pay is super transparent. Google tells us exactly what we're spending in which day, on what service, how much data this query run, how much cost this query run per data, per megabyte. So all this info we have, and then we can just like pass it on to, for example, whoever is funding our research, okay? Highlight number 2 is IIM, which is where you administer, where you can administer and share your project with other people, okay? So under this section in here, I could give access to any of you. If I want to work with Dror, I could give access to Dror to be an owner, to be an editor, to be a viewer, okay? And like here, the options are like very large, okay? I'm not gonna get into it now, but I just want you to be aware as a summary at a high level, Google Cloud Services works under a project structure. You have billing and you have the IAM services in which you can grant permission to other folks, okay? All right, so let's delve now into BigQuery in and of itself. To go to BigQuery, essentially you can, if you click in this panel, you will see here all the products available. One of them is BigQuery, so I can click BigQuery here. Another very convenient thing is I can type BigQuery in this search bar, and I can also access BigQuery from here. Okay, so I click now, boom, I'm moving on to BigQuery. Now I'm inside the BigQuery application, okay, under Google Cloud Services. See that I still have this header I had, okay, in here. So I can be in BigQuery and I can change from one project to the other. Now everything will change, but I'm still under BigQuery, okay? So again, let's go back to my project. Assume I only have one project for now. And once I am in BigQuery, the first thing we need to do is to learn how to access data, all right? So there are mostly two ways to access data on BigQuery. One way is access data that someone has already put up in there, such as, for example, Matt and Dror did with the NBR i3 initiative, okay? So let me show you an example. So again, you will get very familiar by the end of today with all these like panel on here, but essentially think of this as your Visual Studio, okay? Think of this as like your data or R console, okay? this is where we're going to be managing absolutely everything, writing the queries, writing other pieces of code or scripts in Python, for example. We can do that from here. I'll show you at the end of the session, and where we store our data or where we see the data. Now, this is your repository. In this panel here on the left, you see this is going to be your repository in which you're going to access your folders of data, you're going to access your queries, and you're going to access any resource you need for your projects. These resources are going to show up in this panel on the left, okay? And these are structured, again, under projects. So note that this project that I set as a display name, I set it as intro to BigQuery, but this project reminds that it has a unique ID that in this case, Google created randomly. And this is my project, okay? This is the ID I'm seeing here, okay? Now, if I just untoggle this, I see all the resources here. Still for now, I have no data, okay? So how to put data into my project to work with? So first part of the process, load data. There are many ways. I'll show you 4 ways today, okay? Hopefully real quick. You have to go here, this top button at here and say add. This essentially is add data, okay? In general, this is very complex. This is a very complex tool. You can do crazy, crazy things with all this, okay? But in general, let's assume this is only to add data. As you can see already, you have a panel on how you want to add data. All right, so the 4 ways I'm going to show you. One way is, for example, Google has a curated list of data sets that they call public data sets. So I can navigate and search for public data sets. I can click in these public data sets. Now I can navigate here and can, for example, okay, you are innovation folks, so I can say Google Patents public data. And I find all this stuff, and I can access all this data. I can click to this data set, and I can say, hey, view this data set. And this is going to automatically upload this data set in my working environment, okay? This I don't like what Google does. Essentially, they launch a new tab, but it's okay. It's the same thing, okay? So where I was and what I have, look at what I have now. I have now 2 projects in my resources panel, right? I have my project, but I can also see now Patents Public Data Project, which is the one that I just pinned from this publicly accessible data curated by Google, okay? Now, this is a resource that is mostly contained data, and I can open this and see all the data that I have available already now here. Quick question, can someone let me know if the size of the screen is good for you? Can you see what I'm doing? Someone, thank you. So now I can access all these resources, which essentially are data, okay, under this data set. This is already uploaded. So in just one click, look at what I created. I created an access to all the publication, all the patents published under the Google data set, which has 158 million patents, okay? This is a massive data set. You can preview it. I'll show you this, the intricacies of all these things later on, but now just to give you a big picture, okay? I have the data loaded. I could now query this data and do whatever I want with this data, okay? Just loading this data set in your computer would be a nightmare, okay? This is a data set that I cannot load physically into my computer because it has more memory, it has more storage than my computer can handle, okay? 2.50, whatever, terabytes.
Hey, Roger, sorry to interrupt, but some people are asking if you can make the font size a bit bigger.
Absolutely, that's what I was asking. Yeah, a big, how about that? Better? Okay. So, okay, right? So one way, I'll stop here, is I can access data that is publicly available out there, curated by Google. Many interesting data sets. Now, this project, I'm not getting billed for this project because this project someone else is hosting. I can access it, but I don't pay for it, okay? Unless I run a query on the table, okay? There are 2 ways to pay, or there are 2 ways to incur on costs in BigQuery. One is a storage under your own project. In this case, I'm not storing this data. Or the same you're going to see now, NBRI3 is paying for the hosting services to store all the data we're going to see. The other way to incur in costs is to run queries. But because I didn't run any query, I didn't incur in any costs so far. But I want to get rid of this project, so essentially I can unstart it, and then it goes away, okay? Second way to access data, again, I'll go to add, and in this case, you can access on BigQuery, you can access any data set that someone has uploaded on BigQuery. As far you have permissions set via the AIM that I showed you before, right? As far as you have permissions, you can search for projects of any person, right? Nicola can set up a project and share it with me if he wants, right? But the way it works is you have to find this resource, okay? And this is done via this button here that says start a project by name. I click in here, and the point is this is not accessible for everyone. So you need to know what you want to get, all right? But in this case, I know these folks at the i3 initiative have a very cool public data set, and I know that you access it by typing the kind of the URI for this data set, which is called NBR i3. So I type the URI of this data set here, or this project in here, and I say start, and all of a sudden I have it on my project accessible, okay? So now I've been talking, I don't know, for like 15 minutes maybe, right? But this would take 1 minute for you to do. So in 1 minute, you can access all this data that Dror and Matt put up together, okay? Again, you're not gonna pay anything to have this data available for you to query at any time, all right? So here you can see already, again, this is a project that only hosts data. And what I see here are all these data sets. And inside every data set, I can see the tables. For example, if I go under OpenAlex, which is what I'm gonna be working today, mostly, I see all the tables that OpenAlex has, all right? And I can access this. I can access the publications table from OpenAlex, which is called Works, okay? OpenAlex has a fantastic documentation. You just have to access it online. Everything is very well, extremely well documented, okay? And I have this table already here and ready to work with, okay? Good, so now note one thing, how BigQuery organizes the data. The data is always organized in the following way. It's organized in the way of project. Under a project, I can have many data sets. Each of these folders, right, are data sets. And under each data set, I have tables, right? So this is the table that actually contains the data, right? This is, for example, the data set that Matt was saying before that I created with my advisors at Duke, for example. So I have this project. Under this project, we have this data set. I have this data set. Under this data set, I have this table, right? And the table contains the data that I want to query at the end of the day. Okay, so this is how projects and data are organized and stored. Good. Other ways to upload data. So third part, these ones are data that were available already on the cloud. Now, of course, I can upload my own data, okay? Now, number one is very simple. I can upload a local file. So I can just like come here, this panel. I can say browse. I have here R&D dollars is a fake data set. It's a CSV. It detects it's a CSV, okay? I have to say, hey, under which data set I want to store this data. Now, this data is not going to be stored anymore in the NBR i3 because I don't have permissions to write in this project. This data is going to be stored under my project. So from now on, if I upload this data, I'm going to be paying for the hosting, okay? So I need to choose a data set. I haven't created any data set yet. So let me go back for just a second. And what I want to do is I'm going to go under my project and I have no data set. Remember, the structure is project data set table. What I'm trying to do is to upload some data in a table format. I need to first tell BigQuery, I'm going to store this table to a data set. So let's create this data set. Let's create this folder. I could have created the folder directly from where I was, but I think this is more illustrative. So I can go here and I can say, hey, create data set. I click on these three buttons here. I create a data set. I name my data set, I name it canonical, for example, which is kind of like a best practice when you work with data. And this data set is gonna contain raw data that I have not processed, for example. I'm calling it canonical. Now, BigQuery and Google Cloud Services in general, this is a very intro session. I'm not gonna get into the regions stuff. This is like nuts, okay? I still don't understand how the regions work, but two important things in regard to regions. You have to select where your queries run, in which servers from Google that has around the world, all these data centers, right? And you have to select where this data is stored. Now, in general, for now, there is no, for an entry level, this is irrelevant, okay? But these regions will affect first performance, okay? So imagine I have a web application and I have lots of users that come to my web application. I wanna have usually the data and the code to be run close to where the traffic is, for example. In our case, as a researchers, this doesn't matter much. Like the differences are going to be very minor. So this is irrelevant. Second thing that the region affects is the costs, okay? Google will charge different costs for different regions. And the third thing, very important for European folks, that I see that I have here some European folks, I think that in Europe, and I'm not familiar with that, I think that in Europe, to comply with the GDPR, you need to set specific regions, okay? You need to store specific regions, and this I will leave on you to make sure you follow what you have to follow. But here, what essentially you would do is to say, like, I want to store my data in this region, which is going to be Europe, Central, whatever, okay? Belgium or Netherlands. Some of these are selected data centers for the GPDR, okay? So I'm gonna skip this a little bit. For now, I'm gonna say just like, okay, sorry for that. I'm just gonna, sorry for that. Create this data set, I'm gonna name it canonical. I'm gonna say multi-region, I'm not very concerned about that. I'm gonna forget about advanced options for today. And I have the data set, okay? Now this data set is empty, it has no tables, and now I can upload my data. So I can come here, add, I'm gonna browse, I'm gonna add a CSV that I have prepared. I'm gonna say, hey, I want this under my canonical data set. Now it shows up in here, okay? Or I could just type the data set that I created. I want this. I want a name to the table. I want to name the table. So essentially, I'm gonna have the same name as the file that I'm loading. And then there are a bunch of functions. Function number one is I'm gonna ask BigQuery to auto-detect the schema. If your data is clean, 99% of the times, this won't throw any error. So essentially, BigQuery will automatically read your CSV, it will parse it, and will identify every column with the name of the column and the type of the data under every column, okay? So I can auto-detect. You don't want to go beyond the auto-detect, then it's very messy and very tedious task, but eventually, if you use a lot BigQuery, you may have to fine-tune these schemas manually, okay? Now, this is advanced partitioning and cluster. These are for like important for efficiency in terms of speed and cost, but I'm gonna skip today. And advanced options are important and are not that advanced, okay? So I want you to pay attention on that very quickly. The first thing is if you are uploading a CSV that is not a CSV, it's not comma, but it's a tab separated, you say that in here in this field, in advanced options, okay? Other examples is you want to usually select jack rows. Jack rows means BigQuery, if your CSV file has missing data, BigQuery, like depending on many things, but for example, if you have missing data on the last column, BigQuery could skip this row. It could think that the row is problematic and could skip the row, but we have missing data all the time, right? As researchers, for example, I was working on a project on M&A, and the prices for M&A are missing all the time, right? And I don't want to skip these rows. I want to see the missing price, the row with the missing price anyways. So allowing for jack rows in general is important, all right? Now, again, all this under your own risk, okay? Under your own risk for the implications for your research. Another nice feature is many times when you upload data via BigQuery, via this feature here, the uploading of the data will throw errors, okay? And you may want to allow BigQuery to upload data despite these errors. And you can indicate this in here, number of errors allowed. And I can say, hey, I'm gonna upload a CSV file that contains 1 million rows. You can allow for 100 errors and still upload the data. And then, because when BigQuery uploads data, it parses row by row. If in row number 6, it throws an error, BigQuery is gonna stop, unless I allow for errors, okay? Now, this I often do, but one very important caveat for us researchers. Be very careful, because if these errors are correlated with your treatment or control, then you have problems. And it happens. So think about which are the lines that can throw an error when I upload data on publications. These lines could be, for example, titles, and could be titles that contain mathematical formulation, right? That messes up with like the parsing of the data because of the characters in there. Now, you don't wanna just by brute force drop all this data. And if you do, you wanna make sure which type of data are you dropping, because this could then affect any results down the road, okay? Downstream in your analysis. So that's one important caveat for you. You can allow for errors, but be very careful in what errors we are allowing when we are uploading data to BigQuery. Now, this might seem unfamiliar with what you do, but if you're interested in BigQuery, in principle, is because you're gonna work with large amounts of data. And when you work with large amounts of data, these things happen, okay? Good. Then I can just create this table. Table is gonna be quickly created, and I have now access to the table in here. You see, I can access the data now. It's ready for me to work with. Okay. And finally, I have another way to upload data, which I'm going to be very quickly show you, which is via Google Cloud Storage. Google Cloud Storage is another product from Google Cloud, okay, that I can access clicking in, sorry, that I can go to Google Cloud, sorry. So let me go back now to my homepage on Google Cloud Services, and I can say, hey, I want to go to buckets. Buckets essentially is your Dropbox folder, okay? It's your Dropbox service, but for massive data. You can store whatever you want. This is unrelated to BigQuery. I can store video data. I can store audio data. I can store text data. I can store nice CSV. I can store whatever I want in here, okay? And this works at the unit of a bucket. So every bucket is a main root folder. And within our bucket, I can upload data. And for example, here I prepared this as an example. This is PatchStat, okay? When you work with PatchStat, PatchStat has 25 files because the data is partitioned, okay? And you would have 25 files in here. I only added 2, okay? Now, once you have your data uploaded in a bucket, what you can do is just load data from BigQuery, you can load the data directly from a bucket. And this is a feature that you're gonna use a lot, okay? This is how I upload my data to BigQuery. So essentially, remember I was in my project, I say add from cloud storage. I'm gonna navigate to my bucket, and I'm gonna say, hey, I wanna upload this, okay? And now, I'm gonna be real fast here, but this is a beautiful feature because I can say, I actually don't wanna upload one file. I wanna upload all the files at the same time. This is called a wildcard, okay? So I just type an asterisk, and because I have the .csv file, this is telling BigQuery, hey, any CSV file under this direct address, upload it together in one single table. This is a superpower, okay? So I'm gonna say, do that. The data set, I already have it, canonical. This I'm gonna name patstat 24, whatever, 12. How to detect the schema. And I'm gonna go to advanced options. Now for the sake of the example, I'm just gonna type here, I don't even know, but I don't wanna throw any error. And okay, this should be good. Create table. Oh, sorry, make sure all fields are correct to continue. What is the problem here? Don't go too much. I put more errors than rows I have, and it detected, okay? So create, now it's creating this table, all right? Now, this is gonna be, to me, amazing, because if I had to merge all this data on my computer, now this is gonna take 2 minutes, or not even 2 minutes, 1 minute. In my computer, this would be like a nightmare. I would spend 3 days, and I would even succeed. I wouldn't even have succeeded with it, okay? Now, again, and see that this is automatically concatenating one file after the other. And I only had 2 files, but I could have had 1,000 files. No matter what, it's done. Now I come to my canonical folder here, and patch that is loaded automatically, okay? I have here the schema, which contains essentially the columns. I have a preview of the data. This is loaded nicely. And I loaded with less than a minute. I loaded 91 million rows, okay, of patch-stat patterns, okay? So that is a superpower. I know I'm spending a lot of time, but again, I want to show you essentially kind of like the big picture of what you can do rather than delving deep into one single thing, okay? Awesome. Good. Any questions that are important that you want me to address, Dror? I don't know if you want to create some questions, or I'm going to move into the next section, which is querying data, manipulating data.
I'll just add one small thing, that if you would try to upload a CSV directly, like Roger showed at the beginning, it's going to be limited to like a few megabytes. That's why you need the Google Cloud Storage. If you want to upload bigger data, then you have to go through that first and then do what Roger did.
That is totally correct. Thank you, Dror. And it is a very important point. Actually, this is right, okay? And the same will happen when we download the data. So why when we have a question, I can take this question real quick and then move forward, okay? And any questions, please type in the chat and Dror will curate, or at the end, we have a 15 minutes Q&A that I can address. But if you wanna just ask the question now, you can, I'm happy to answer it. Anuba.
Just simply a clarificatory question. Does this also accept non-CSV type files as well, like Parquet or Feather?
Absolutely.
Because I
Yes.
generally use them because they're
Yes.
more efficient in storage.
Absolutely, absolutely. And I didn't touch this because this I think is more advanced, but you can, when you upload a file, okay, whatever it is, a local file, for example, I can say the format, and it can be an Ivro, a Parquet, whatever, you see? Okay. And obviously, if you deal with Avro files, probably you're gonna be doing this from your command line, not from this interface. But I didn't touch this because this is kind of a little bit more for the next session. But yeah, absolutely. You can upload Avro and Parquet, you can do it. Either from a local file, from the package, from the command line, okay? Great, so now let's see how to query data, how to manipulate data, okay? Let me start with basic querying. So I have a cheat sheet here that I prepared. So let's say that we want to get a table, okay? You see my screen, I can command. Now this is the SQL editor. Let me go back just for a second. This is the homepage of SQL, but essentially now if I click this button here, okay, I'm opening the SQL editor. And this is just essentially a text editor, my scripts that I'm going to run, okay? Now, let's say that I want to create a table with papers that have more than 100 citations and that are published after 2010, okay? Again, now we already have this data available. We know how to upload it or how to access it. Next step, let's manipulate data. Let's play with the data. So first thing is, where is this data? This data is incredibly well hosted because you all see these results here, but I can promise you this is very painful to process. And so we have this table nicely uploaded in here. And one other nice feature from BigQuery is that I can split my tabs and I can keep my data on the left and I can have my query on the right. And I say, okay, I want to create a table for my research that contains these conditions. This data is on OpenAlex under the works table, which contains publications. And as I told you, this is the structure. Remember, this is project. This is the address, right? The table ID, which is the address of the table, which I will have to indicate in the query. This is the project. This is the data set. And this is that table under the data set under the project. So I want to copy this, which I can copy when I open a table here. I open a table. I have a bunch of features here, schema. And I can see the schema, the columns, and the type of the data under each column. I can see the details of this table, okay? Rows, the weight of the table, okay, and so on and so forth, and I can preview it. Okay, so here you have the address, which I can copy, or I can copy from other places, or I can just type it, but this is what I want. Okay, I want to query this data. Now, SQL, and again, this is not a class on SQL, okay, but I will try to convey like the basics. SQL, essentially, it's written in a way that I never understood, but it's written in this way. I want to say from, okay, this table, okay, from this table, do something. That is kind of like the idea of BigQuery, okay? From this table, do something. And this is different than Stata, in which we only upload one data set. And this is different than Python, in which I can access many data sets in different ways. This is SQL. And I'm going to say, from this data set, do something. The way to indicate a data set or an address in SQL is by adding these backticks here. This is not a quote. This is a backtick, okay? These backticks you access from the top left, usually a top left in your keyboard under the escape button, okay? So I want to say from this data set, do something. Do what? Give me all this stuff that I want. Give me publications, blah, blah, blah. Okay. Now, the next step is say, I'm sorry, I didn't tell you, but what I would like to do is I don't want to get all the data, but I just want to get these variables over here, okay? I want to create a data set that not only contains these conditions over here, but I don't want all the data because, you know, like OpenAlex has stuff that I don't care, updated or type ID or the bibliography. I don't need it for my research, right? Or the mesh keywords. I don't need it for my research. So I just want to select a few columns, okay? How you do that in BigQuery? Conceptually, and this is where BigQuery sometimes you gotta get used, conceptually would tell BigQuery, from this table, select these columns, select the columns that have a paper identifier. This is here, it's called ID, okay? So select the ID column, right? What else do I want? I want the number of citations. Obviously, I need to get familiar with the data, but you will with your own data. So I want a variable that it's called cited by count, which is here, right? So select me, but please select cited by count, right? And select the rest of the columns that I asked, right? So let me just now go to my cheat sheet, essentially. and copy paste, but the idea, I hope that you got it. Select all these variables, right, from this table. Now, for some reason, I never understood, this statement goes at the top, okay? But to be clear, and I'll show you now, how SQL is processed is starts in the from and then processes the stuff at the top. So this is like a very nice way to write it, but it's not how it's processed. So, and I'll show you this is important for why it's coming now, because I said, hey, I don't only want these variables. I don't not only want these variables. I want from this table, these variables, as far as the rows meet these two conditions, right? And so I'm going to pass the conditions in here. I'm going to say, hey, from this table, filter it, give me only the rows where this is true, these conditions are true, where cited by count is more than 100, and where publication year is after 2010, right? And so again, how BigQuery or how SQL in general is going to execute this command is going to first read this statement here, subset the table based on this statement, and then give me the columns that I requested, okay? This is important because, for example, if I want to reduce costs, I can filter my data sets somehow in here, and I'm going to reduce costs, for example. Anyways, now I'm done. We wrote our first query, okay? And now there are best practices on how to write queries, but usually you format them like that, okay? And there is a button actually that can format the query for you. But this is a nice way to kind of read it and see the query. This is the first query that we wrote. Now I can run this query. How do I run a query? How do I tell BigQuery to execute this query? Many ways, but to get a first idea, I select the statement that I want to run from top to end, and I press this button here, run. Or from your keyboard, you can press Command and return if you're in a Mac, and if you're in a Windows, probably it's going to be something very similar. So I'm going to run the query. And now look that in a matter of seconds, we're going to get the results. It's done. Okay, so we just queried in 2 seconds 260 million rows. You ask this in Stata, my computer crashes. Okay, all right. Good. Now I have a table. This table is temporary. Okay, I didn't store this table. I'll show you how to store later on. But this is a temporary table that I just created in here. And I can see the results. And I can see that, for example, I have 1.2 million rows that are returned that meet this requirement. From the 260 million rows, only 1.2 meet the requirement. And I have the data. I could just download it right now, okay, and start working with it if I want to. Good. Okay, so again, in the interest of time, I just want to give you an overview, but you can do many things with this, okay? Other things that you can do is say, okay, I can rename these variables, and I can say, hey, the cited by count is very large. I want to say it's sites, and this I want to rename it as pub ID because I will have other IDs such as patent IDs, and these are okay. So I can do that. Other things that I can do in a query, and again, let me insist, I don't expect, if you're not familiar, to follow perfectly, okay? But to give you like the broad picture. Other things that I can do is I can create new variables in my output table, okay? One very simple variable is, imagine I want to know which day I downloaded this. So I can create something like, this is going to be the date of today, right? Today is what? Whatever, 2025. What day is today? February 21 as export date. I can do that. And I can do more like advanced stuff like, imagine you want to run an event study and you already know that your event year is 2016, right? I can already create a dummy, for example. I can say, hey, a conditional clause. I can say, hey, case, when the publication year is, right? When the publication year is more than 2016, then give me a 1, else give me a 0, and this subquery in here. And then we're going to name this as, I don't know, dummy event, okay? So I can do this, and I can now run this query, and I can do more stuff. Like, by the way, I want the results sorted, okay, as you would do in other languages by the publication year, and sort them like in ascending order. So I can also do that, okay? Bunch of stuff you can do. I can run this query, and in a matter of seconds, again, it's gonna not give me what it gave me before, but I changed now the titles of the columns of the variables directly in here in the query, and note that I added these 2 columns in here in the dummy event. This is 0, and if I go to the end of this data, it will be a 1, right? You can do all types of operations. One disclaimer here. SQL is much more limited than Python, for example. In Python, when you create a data frame, you can do all types of crazy stuff. Everything you can do, everything you can imagine. In SQL, it's a little bit limited. It means that sometimes you have to create intermediate queries, okay? Not any type of operation you could do. If you have to concatenate two operations together, such as first compute the sum and then give me the average of these sums, sometimes you cannot do that. So Python in this sense is much more flexible. Okay, so that could be kind of like the basics at this point on how to query data. Now, imagine I want to store this to download it. Most of you may have seen already the save results button, but that's not kind of like the best way. When you're familiar with it, you can do it if it's quick and you want to do something quick. But the way to kind of like store this query in your data set here, remember I have my data set under my projects, is I'm going to pass yet another clause that will tell BigQuery to store the results of the query into a table in the data set that I point to. How do you do that? You essentially just say create or replace table. I'm going to pass here the address as. And now this command here is telling that the output of this query be stored in my data set. My data set is, in this case, I can create a data set because I'm manipulating data. So in this case, I can say create a data set, and I'm going to name it derived, which is all the data that I manipulate. I want to be stored and not messed up raw data with manipulated data. And so I want to store this in derived dot, and then the name of the table, right? This table is going to be table 1, for example. And the address of my project, you don't need it, okay? Whatever. You could add here at the beginning the address of the project, but because I'm storing this in the same project I'm working, I don't need it. Essentially, now I run this query, and what this is going to do is instead of returning a temporary table, it's going to store it in a new table in here. You see? Boom, it appeared. And now this table, I can access the table forever and ever unless I delete it. Now, all these queries had a cost, very little, it's minor. And then storing this table is going to have cost moving forward, also very little. But you see the results are now here. I have 1.2 million rows. This is like the size of the data set, some info, meta info, and I can preview this data, right? And now I could download it from here, which is what often we should do, okay? Good. So that would be the first part. I'm going to show you how to, for example, do a merge, okay, and see the power of a merge. Imagine you want now to bring in data from Matt, and you want to bring patent citations to this table that I created here, right? What I can do is a very quick merge, and I can start merging data sets, okay? So how I would do that? I want to, essentially, I have to get familiar with the data. Matt's data is in here, reliance on science, and he only has one table in this data set. Let me move this to my panel with data. I need to get familiar with this data. Essentially, I only want to know how many patent citations a paper has, right? I have identifiers here. These are the paper identifiers. And so how I would do that? Essentially, what I would do is how I'm going to do the merge, and you're very familiar with it, merging data. This is the key for the merge. Matt calls it OA ID. I call it PAP ID. These essentially are the OpenAlex IDs that Marx gives us in his data set. And this is how we're going to merge the data. And I care about how many patent citations, right, a given paper has. If you're not familiar with this data, essentially Matt has here pairs of patent and papers citations. And so I can have many to many. One paper can be cited by many patents and so on and so forth, right? So the data here is repeated, so I'm going to deal with this too. This is going to be a little bit of a more advanced query, not too much, okay? So how I would do that is first, let me see. Let me write this query for you. So what I would do is like, I would say, hey, I had this data, right? That's the data that we were selecting from the first table, right? Let's keep it simple. Let's remove this stuff. Okay. Let's remove this stuff to keep it simple for you. And what I can do now here is say, this data, I want to bring in the patent citations. So essentially I have to merge first, right? By ID, how many patents are citing each of these IDs in here. How you do that in BigQuery is, and this is a little bit more advanced, okay? But to give you like a preview, you gotta name this table. Now I'm gonna name the output T1, okay? And then I'm gonna say left join. This is a left joint, okay? And I'm gonna select the data that I want to join. To start simple, I want to join these two variables from match data set, right? I wanna join this patent. This is what I join. This is gonna be wrong, okay? In case someone is already thinking this is wrong. Yes, this is wrong because this is not gonna give me what I want. This is gonna give me a data set that will include all the paper patent pairs. And it's gonna mess up with my data because essentially I will have duplicate paper IDs, okay? But bottom line, this is to start and give you a sense. This is how I would run a merge query. That I'm creating a new table on the fly, right? This is the table that I want to merge from the right. I'm gonna merge this table that I'm creating here to my first table that I already created. And I have to pass a key here, right? So merge, this is gonna be named table 2. And how you're gonna merge this? You're gonna merge on T1, on the ID of table 1 equals the ID of table 2, right? Now, how I do that? I have to indicate that this ID here is in table 1, and this ID in this variable here is in table 2, okay? This is how I would do it. This will throw an error because these IDs are not matching, okay? Oops, sorry for that, left join. Left join. This will throw an error because I'm not matching the IDs now. Okay, it's then telling me like, listen, these IDs that you're matching here, the keys are not correct. Your string versus like an integer or whatever. It has an easy fix, which you can do in BigQuery. So essentially, Matt's ID is an integer, but the ID that comes from OpenAlex is not an integer. So I have to transform it into integer. I can do this here with this type of int64 with this command. Now, this still will throw an error, because the ID in OpenAlex, sorry, has text in it. So I cannot even convert this into an integer, okay? If I go to the ID, that's how OpenAlex writes the IDs. But I can also solve this in my query very quickly. So what I'm gonna say is trim this variable by removing this text from the variable, which is what Matt did in his data set when he created the IDs for probably efficiency purposes. And what this is doing is, look, listen, this variable from my T1, remove this content and then transform it into an integer. And this is gonna give me a variable that now I can match to Matt format, okay? And now I can run this, and this is hopefully gonna merge the data, okay? Now, this is not correct, as I was saying. I will skip that in the interest of time because I see I talk a lot and we're running short, and I want you to not to go over it. But this is nice. This is correct, okay? We got the data very quickly. This is a nice merge of, in this case, we end up with 3 million rows. Now, this is not correct because I should group this data, which is an operation I can do, okay? Essentially, what I wanna have is just one paper in my unique papers in my data set, and then how many patent citations are citing this paper. This I could do with a grouping operation, actually. I could say here, group by OA ID, and then just give me the count, okay, as patent sites. And this is gonna be as paper sites, okay? And just to show you how this kind of would work, you would write this query, and then this would give you the results, T2 dot sites, okay? Again, I'm well aware, and this is by design. I'm well aware that most of you may not have followed what I did. This is by design. We just want to convey you what you can do with BigQuery, okay? It's not an SQL class. Learning to run this query, when you have most of all believe in incentives, right? When you have an incentive, which is to get your paper done, and if you have to run this query, you will learn how to run this query real quick with the help of an LLM or whatever. But see the output, how quick it was. Now I have the data set I wanted. Note that I have 1.2 million rows, which is what I originally had. And note that I have a column, which is patent sites, that indicates how many patents I have now, okay? Matt, are you talking to me? No, okay. Okay?
I'm just
Good.
expressing amazement. Like this would have taken me like
Yes.
a day to download the OpenAlex data. I would have had to
No.
create temp variables, do this. I'm stunned. Keep going.
It's impressive, okay? And you will think that writing this query, of course, I did it quickly, but it's not really difficult for you because you are all folks familiar with managing data. It's just like learning how to run this query. And again, you ask it to ChatGPT, it will throw it for you. And as soon as you run 4, 5, 10 queries, you work a week with it, you are done. You will have the basics. So I really encourage you to just like overcome this little like first friction. You could do many other things, okay? I could automatically process this. I don't want nulls. I hate nulls. So I can say, hey, give me this is going to be a 0 if it's a null, okay? BigQuery or SQL is a fantastic language once you're familiar with it. Okay, in the interest of time, let me move to the last, and I skipped many things, but let me move to the last step, which is, okay, I have manipulated the data, and now I have a table, actually, that I want to download, right? And let's say that I want to download this table that I just created here, and I'm going to name this as table 2. So I'm going to, again, store this table in my environment under my project. Now the output is going to be showing up in here as table 2. Okay. Table columns must be named. Okay, sorry, I gave here as patent sites. Okay. Usually the error handling is very informative from SQL, and it helps you really debug quickly. So we're done. I created this table. It's here. I can access it, do whatever I want. Now imagine my goal is now to see whether like the author count is correlated with patent sites or with paper sites, right? What I would do now, and I can add like year fixed effects with the publication year, right? So I would download this and then in my case, you do whatever you want. What I'm gonna do now is I'm gonna download this and run it in my Stata, right? How to download data? Real quick. And I hope you have 5 more minutes. Dror,
Roger,
go ahead, Dror. Yeah.
could you just say a word? There was a question in the chat about
So-
incurring costs of running a query.
Yes, and I didn't mention that, and it's a very important question. Thanks for raising this. So, 2 ways in which you incur costs in BigQuery, as I said. One is when you host data here in your personal project, okay? This table has a cost. Storing this table over time has a cost. These costs are minor, and you can check this cost under your billing and cost panel on Google Cloud, okay? So that's one thing. You cannot check exactly from BigQuery how much storing this table 2 will cost me. But now I could go to billing. I'm not going to do it, okay? But I could go to billing. I could find how much I'm paying every single day on any use, on any service I'm using from Google Cloud. And one of the items will be data hosted under BigQuery. These are these. And I will see that this would cost me 1 cent a day of $1, literally, these tables, okay? That's cost number 1. Cost number 2, which is a very important question, which is where the costs start rising, is when I run a query, okay? Now, this you can know in advance. You can know how much a query is going to cost you before running the query. How do you know that? Imagine I want to run this query, okay? I select the statement, and can you see here in the top right of my screen, it says this query will process 16.4 gigabytes, right? Okay, this is the cost. It's a proxy. It's a okay. I have to multiply it by the cost per gigabyte, but this is essentially the cost. Now you could go to, and I'm not going to do it, but you could go to pricing, BigQuery, and you will find very quickly how much it's going to cost you to run a query. Okay, queries on demand, for example, if you are in the US like I am, it's going to cost me 6.25 per terabyte. And by the way, if you have your credit card introduced and you activate it, not only you have $600 or $300 of free credit, you also have 1 terabyte free per month. And Google is not paying me for like Google. No one is paying me for doing this. Not Google either. Okay, so you can use anything that you want, but I'm not trying to sell you Google. But it's pretty good actually, right? They will offer you 1 terabyte for free every month, and then you will incur in cost. Which costs? You will pay 6.25 per terabyte. This query was like 16.4 gigabytes, so you just make the calculations, right? I divide 1 terabyte or I divide whatever, yeah, right? And I will get the cost, correct? It's just like basic operation. And I could know in advance how much this is gonna cost me. This cost will show up anyways in my billing account, and I will be able to see, so for BigQuery, I will be able to see how much I paid for queries and how much I paid for hosting data, which is what I was saying. It's very, very transparent and very useful. Good. So to finalize, to download data, which is very important, and I hope that you have 5 or 7 more minutes, and you can stay for these 5, 7 extra minutes, because this is very important and tricky, okay? So I want to give you the overview. Once I have data that I have processed, and this is entry level, this is basics, okay? You can run all this stuff from others. You can run queries on BigQuery from Python, which is what I do often, okay? And then you don't even have to download your data on BigQuery because your data is gonna be already on your Python environment, on your notebook or whatever. But this is for another day. So to download this table here, the simple way is I click on the table that I created, that I want to download, and I have a button here that says export, right? Remember I had the schema, the details, the preview, and I have a button that says export. I can click on this button and simply export a CSV file, okay? Where do I want to export this CSV file? Don't have to be compressed. And I export it to my buckets that I showed you before, right? So when you download data from BigQuery, the buckets, as Dror correctly pointed out, are key to manage the data, to upload and download data, unless it's a very small, tiny file that doesn't go beyond a very ridiculous amount, which I think it's like 100 megabytes or 10 megabytes, I don't know. You cannot download the CSV directly from BigQuery. You have to export this CSV to the bucket, and then from the bucket, you will download it. So I could do that right now. I want to say, hey, store this CSV to my bucket. Okay, that's not correct. And name it table 2. And so I want to, this is Google Cloud Service location. Okay, and this is the bucket, CSV format, no need to compress. I could compress it, save. And now you see here this message, export is initiated. And when it's finished, it's going to say export completed, export finished. You see? Now, if I go to my buckets, which I could just type buckets here, if I go to my buckets, which again is a different service from Google Cloud that you pay for, so now you're paying twice for the same table, okay? Pay attention to this and be sure you are efficient in managing this data. To go to my bucket, you see I had to select the project. This bucket is unique to this project. And I have my bucket here, and I have the table. Look at that, okay? It's in here, and I can just download it to my computer, okay? Now, okay, part number 1. Part number 2 is this never works to me. I hate this process, okay? Because you're not going to export one table that has 10 megabytes. You may export like a table that has, I don't know, 3 gigabytes that you are comfortable still processing in data, and that has like text, and that has like blah, blah, blah. One caveat that is the only not nice thing about BigQuery is when I export a table from BigQuery with the process that I showed to you right now, if this table is beyond 1 gigabyte, okay, BigQuery will automatically partition the table, okay? So what I would get as an output in my bucket wouldn't be this nice table 2 CSV. I would have gotten 100 files. And I hate this, especially if I want to work then with this data to just run my regressions, right? So I want to show you my trick, which is a very well-known trick. I'll show you what I do, okay? Because I don't like BigQuery to partition my data. And there's no other option. It will partition your data if you export it into a bucket using the UX, which is what I did, right? Using the platform. So what I do in this case, and now recently BigQuery facilitated this a ton, is I do it with Python, okay? And you don't need to know anything. You just run the code, and I'll show you. This is very easy now because before, up until 6 months ago, you had to connect your Python environment to have permissions to access the data, write, read data on BigQuery. So you had to manage the permissions on the 10. Now it's even simpler because you can launch a Python notebook in BigQuery. If I go here, like let me, for example, go, like, let me close all this stuff. Oh, by the way, sorry to go back and forth, and I hope that this is helpful for you all. One small note that I forgot that's very important. You can save all the queries, okay? This query, this script, I can save. I can just say here, I can just say save my query, save query. It's very simple. You don't need to know any advanced option. I want to name this query intro day, whatever. You can say, again, you can region, don't worry about that. I can save the query. Sorry for that. I forgot about that. And now my query appears here in my resources. Remember, under my project, I also have the query, okay? Good. So sorry for this small note in the middle. So what I was saying, okay, I have this query, it's saved, so I can close it and I can open it again if I want, and it's back as it was. When I have this panel or from there, I can open something which is called Python Notebook, okay? I open a Python notebook, okay? And essentially, this is directly connected to all my resources in this session that I have right now under this project. And the beauty of this is that I can tell Python, like they even themselves, now, and this is new again, they give you the data that you need. So essentially, I can copy these, okay? This is an example that these guys are giving us. But I can say, hey, Python, I have to run the query, but essentially I'm going to say select all. I didn't explain the all, but when you want to select an entire table, you just say select all. It's called select asterisk from, okay, we already kind of saw this. I want this table, okay? So look, this is a query, right? This is a very simple query. The query is in here. This is Python, okay? But I'm passing a query to Python. The query is this one. The query statement is this one. Select absolutely everything from this table. Don't pass any filter. It's the most simple query one can write. This is going to return me the entire table. And what this is going to do is impressive because it's connecting to the runtime, whatever. It's going to take 1 second. But what this is going to do essentially, it's impressive because it's going to give me a pandas data frame of my table. No matter if my table is like 5 gigabytes of size, no matter what it is. And why is this? Usually this is now loading, but when it's not loading, it's not the first time, it's really fast, okay? It's saying allocating runtime here. And this is because I'm connecting to the servers. But if you're not connecting to the servers, this is real fast. So essentially, and to move forward, this is gonna give me a pandas data frame, okay, once this connects, of all my table. My table will be converted into a pandas data frame. And the code that I'm gonna run then, that I have here in my cheat sheet, is this code, okay? This is gonna store the results. Shoot, why is not? Okay, this is not. Wait. This is because I'm forgetting, sorry for that, huh? I'm forgetting this, okay. This is gonna create this pandas data frame. It's gonna name it results. Okay, now we're okay. Okay, just bear with me 1 more minute and I promise we're done. Okay, now look at that. And I promise you this is very useful. I have my results in my table in a pandas data frame, right? No matter how large this pandas data frame it is, then now I can run this command. I can tell BigQuery, I can tell the Python notebook, hey, download this data set. By the way, to start a format already, I don't even want a CSV, I want to start a format. This is what I do. For security, I convert everything to string because otherwise sometimes I get problems. And then I destring the data on Stata myself, okay? This may be back and forth, but it will save you probably a lot of time because it will not throw errors. So for security, I'm saying, hey, the results, convert everything into string, and then convert it into Stata. And this is going to be table 2. I pass the version I want from Stata. This is Python, it's not SQL anymore. And now here in my Python resources, I will have this data set, okay? And I can download the entire data set already from here. I can download this data set entirely from here. And the beauty of this, now it takes you 5 more minutes, but the beauty of this is you will avoid dealing with 1,000 files in a CSV format that will have been updated into your cloud storage. So the counterfactual, I know it's taking a little bit of time, but the counterfactual is like very, very like tedious, okay? Dealing with 1,000 files that you just wanna process, put together for data. Okay, so now this should be appearing here. Results should be appearing here. I don't know, it's table 2. For whatever reason, it's not, but it should be. That is like problems of like doing live demos. But you get the point, right? There is, I'll stop from here. Why is the data not here? The data should be here, okay? Tried yesterday, I think it was here. But whatever, table 2, why it's not here? Content. Should be here, okay? For whatever reason, you can deal with that, but that hopefully that makes the point. I'm sorry it didn't kind of, I don't know what's going on here exactly. It should be there. Now, there is another code I'm not gonna skip, but you can, if this data is very heavy, literally like heavy like gigas and gigas, and it will take a lot of time to download, you can also upload this to a bucket, okay? So essentially, this is a code I have here, that cheat sheet too, but essentially what I could have said is like, upload this to my bucket, and it will upload it directly to my bucket instead of this like local environment. But again, it will upload a DTA file, which is ready to download from the bucket. When the size of the data sets is very large, often it's much more faster to run this code here, okay? than to upload it into a bucket. Okay? So I'm gonna stop here. I'm gonna stop here. If you, I hate it so much that for whatever reason, this is not working. I hope that it should. But do you have any questions? 9 minutes past the time, but I don't know. Dror, Matt, any comments, something that I forgot? Any questions we want to address? Or open Q&A? Up to you all.
Can I very quickly? Yeah, so once you save the table in the local environment, how do you download it in your local machine?
See, if this table were to be showing up in there, that for some reason really should just show up, you essentially say top, you see the data is in here now.
Yeah.
The data is in here now. Let me show you what you're gonna find, okay? So you run this, and then oops, you run this. That's gonna be table 2. Maybe it's because I don't have the directory well set up, but essentially this is what you see, right, Enrico? So you just click here, and you say download.
Oh,
You see?
just like that.
Just like that. Sorry, that's a great question. I'm sorry for that, Enrico. Thank you.
No.
Just like
It's,
that, you download the data set that will be in there, right? Just like that.
excellent.
If this table is 200, 400, 600 megabytes, I would say that's the way I go. If this table is 5 gigabytes, which is data we usually work with, and it's very common still, I wouldn't do it this way. In this case, I would run this chunk of code, which you can ask ChatGPT and it will give it to you. That essentially is I'm going to say, upload my data to my buckets. And then I would just say, hey, this is going to be table 2, and this is going to be table 2, okay? And this chunk of code here, if I run it, will upload my data to the bucket. And then I would go to the bucket, and here the data will be in here, right? And I would download it from there. Okay, Enrico,
And
I
you
hope
can download the big tables from the bucket.
Correct. From the bucket, you can download anything. Also with like these 3 dots in here at the right hand, you click and you say download, and you just download.
Okay.
Now, the problem, since we're delving into it, the problem with this is that this local environment here, if the documents are very heavy, it's not as efficient and not as ready because you're downloading it via different like mechanisms than downloading it from the bucket. So you can really wait for 5 minutes to download a 400 megabytes document. But if it's like 5 gigabytes, it's going to take you 20 minutes or 30 minutes, or maybe it's going to run out, your browser is going to run out of memory, which happens to me. In that case, I upload it to Google Cloud Buckets with this chunk of code that I have in here. Okay. Which I can run, and it says, it's very strange because I don't know where the heck this file went. I should set the directory, but no, look, it says that operation is completely. You see, I just ran this code here, and automatically, hopefully now, I'm not gonna fail. If not, like Matt is not gonna call me again. Hopefully now it's gonna be in here, okay? And yeah, it is. Okay, now the table is in here. You see, I uploaded the table that I processed here. It's called table 2, and I can just download it from here. And this is super fast. No matter the length of the size of the file. Okay.
Okay.
Good. More questions?
Thank you.
Yeah. Hi, Roger. This is very cool. Thank you. So I also have a question on that. Sorry, Python notebook. I think that function is kind of new, right? It is maybe not very new, but I think recently launched. I just have a question. So is this the same as the Colab or?
Yes, that's a Colab. That is essentially a notebook that now I can open in here. That is totally correct, Joyce. And this is very nice because I don't have to set any permissions, which was usually more troubling. What I used to do, for example, I used to have a Colab, and I'm happy to show you very quickly. And in my Colab, for example, which is also the cloud, what I used to do is, look, I have already just like a script that connects to my BigQuery and that just runs the same script that I just showed you, okay? And I would download this data. So, but yeah, that's just like a notebook that you can
That's
access
yeah.
and load in your BigQuery environment, even though this is a BigQuery environment optimized for SQL queries and large data, you can upload a Python notebook. You can even run
Exactly.
regressions right here.
So yeah, actually my question just related to that. Actually, we can actually run any Python code now just in the BigQuery environment, right? This using this
Absolutely.
can directly
Yes,
write Python codes, and this is really
that's
cool.
it.
And let's say if I want to conduct a record linkage, means fuzzy matching, and
Yeah.
I think that SQL might not do very well in that, right? I don't know what's your take, but I think let's say if we need to run a
That's correct. That is an amazing point, Joyce. I think you are right. This is a Python notebook directly connected to my data. The only thing you need to be familiar with is in running this type of code that will transform from SQL to your pandas data frame. And you're done. You can run whatever, machine learning, regressions, anything, plot figures, nice figures, and so on. Now, I learned from Dror personally, because I used to think like you, if I want to run a fuzzy match, I'm going to export my data to Python and run it in there.
Yes.
But Dror showed me that this was a very bad approach because BigQuery is amazing still. Like, if you really are messing with lots of data, there is something that we left out from this session, but you can create functions in Java to run in BigQuery. And then this is a little bit more troubling. It requires a little bit more of knowledge on how to execute a function. But essentially, when I have a query, in this query, okay, in this query here, so I could pass here a function which is, this is my fuzzy function that I just created in JavaScript somewhere else, right, or whatever. And then I could pass here the input, which is the title, right? And then I could store this, and this would run at an impressive speed.
Yes.
You cannot compare how fast this will run to how this is going to run in Python, because once you are in the Python notebook, you are connected to BigQuery, but you're running Python. You are not taking advantage of the way that BigQuery processes data, right? Which is like in parallel, whatever. Okay,
I see.
Okay, more questions?
Thank you.
Roger, I'd like to jump in on a related
Sure.
thing just to show if you could go to the OpenAlex on the NBR i3.
Yes.
If you click on routines, so I uploaded a function just as an example. This will convert the inverted abstract to regular abstracts. So this is an example that's super
Amazing.
useful for our purposes.
That's correct. So what Dror is saying is, look, OpenAlex, I think that for data privacy issues, they cannot, also it's more efficient, by the way, in terms of data. I don't know which of the two it is. Maybe Matt and Dror know. I think it's the two of them. But OpenAlex essentially doesn't store the abstract in a readable way for humans. Now, back in the day when we were using like basic NLP, it didn't matter because you just want to count how many times this word appears. You could kind of sort it out. But today, with like the current techniques, we want to read the abstract in a natural way. So this is not how the abstract is stored. You can see that right now in here, right? It's called it's stored in something that's called inverted index, okay? And what Dror is saying is, what I kind of was saying is, you can write functions, routines that will de-invert this abstract automatically, okay? Now, with your approach, Joyce, which again is what I used to do, for example, so nothing wrong with it, you would have to export this to Python, run the Python script, and then bring it back to BigQuery or no, or whatever. Now, you can learn to write any function that process text, for example, as you were suggesting, or as Dror is saying, directly in the query. And so essentially, in this case, the query would be something like, hey, give me, select abstract inverted index. Let me show you. I think it's a great example. I'll show you now from this table, which is the OpenAlex table. Select this. Did you try this, Dror? Okay, and this is
it works, but it's going to be a huge
no, because
a
we're gonna limit it. So I can say
maybe don't really run it. Just
okay.
maybe
Okay. I can limit. When I pass a query, I didn't show this, but you can limit the number of operations. I can say just do one row, and I can write one row, and it would write. Okay. So this is what I would run, and here I would pass Dror's function. Okay. which is this routine, convert inverted abstract. I would say convert inverted abstract, and I would run this query and I would get the abstract de-inverted, okay? So more questions?
Hi, can I ask an old person question? Okay.
Go ahead. Matt,
So,
please.
so the IT department is after me because all my computer is out of warranty and they don't like that, and they're like, you need to buy a new computer, and I'm like, I don't know what to get. So because I do a lot of big data projects and I keep running out of memory, and so I thought, in fact, there's one figure from a paper I'm working on that I can't reproduce, only my co-author who has a half a terabyte on her desk of memory. And so I'm like thinking of getting a desktop, which I don't want because I travel all the time and I don't want to remote in every time. But now I'm looking at this and I'm like, maybe I can run everything on a 16 gigabyte laptop and just do it all in BigQuery. Is that what you two do? Do you not like have big iron on your desk anymore? Am I thinking wrong about this? And is the future all cloud-based?
Like, I'm happy if Drew wants to answer, but that's how I work, Matt. As far
Yeah.
as you can pay for it, there is a cost, and the cost is in monetary terms. In this case, you gotta pay for this as opposed to run it in your own computer, which in principle has no cost. In principle,
No, but it's going
here-
to be like 15,000 to buy something with half a terabyte of memory. That's plenty.
So if you can pay for this, absolutely. My computer has 1 terabyte of memory, but I don't use it. I don't store any data anymore in my computer, and I only run Stata.
But
The
you have a
Stata
whole
I-
terabyte of memory?
in my computer. Yeah, but I don't use it. I just use it for like, again, okay, everything on the cloud. And I didn't show this, but machine learning, BigQuery data, anything on the cloud, and then I download nice files to just run the regressions in Stata. Okay. Yes, Matt.
I can also add that you can open a virtual machine, which is a virtual computer within the Google Cloud environment that connects to your buckets and allows you can have as much memory as you want. You can rent it by the hour. You pay for its use, and once you're done, you close it down and you're good to go.
May I add to this
Please.
discussion?
Go
So
ahead.
basically, I am from India. I'm doing my PhD from Indian Institute of Management, Bangalore, and we do have less resources than probably the universities you are at. So I also processed OpenAlex dataset for my dissertation, and I had to figure out a way to do it in the cheapest form and the fastest form. So the easiest solution that I could find was to not store data on my laptop, but instead buy these 2 TB SSDs. And I use Python, and Python has wonderful wonderful libraries to deal with heavy data. So I just download bulk and process them in bulk in Python, and that's very much doable on a simple 16 GB laptop.
Yeah, thank you. I think this is great. I mean, the costs are a thing because Matt, you said like this is just like it's 1/10 of like $3, but it will add up. That when you start working sometimes, like if you only work on BigQuery and with large data, it may add up, right? But if you don't have like ANUVA constraints that she's bringing up, this is like much more streamlined. And again, 2 things for me. One is, as I said at the beginning, one is the computing time, right? It's like 100x, as you just saw doing all these merges. But the second one is like my energy in like dealing with errors, which like throws the rest of my day out, right? Like, so your productivity usually should increase a lot, okay? On your own time in terms of like writing code yourself.
Yeah. So maybe I could get a machine that has enough memory to run regressions, but do all the massive merges in the cloud.
You can
Yeah.
you can run it from your phone. I run queries from my phone, Matt. Sometimes just connect to BigQuery. You can try to.
I have research projects which are basically a bunch of queries, as Roger presented, just one after another. In BigQuery, it ends up with a 10 megabyte CSV file that I take into Stata, I run the regression, end of day.
So
Another
go
question
ahead.
Can I?
from an older person again, and maybe a stupid question. Do they charge you only if the query works, or you are charged also if the query fails?
That's a good question. So I don't have a perfect answer. Sometimes, so two things, Stefano. If the query doesn't work from the outset because I wrote it in a bad way, for example, imagine I write a query and I forget the backticks for that table, right? I hope you're still seeing my screen, right? And if I run this query, it's not gonna run, it's gonna throw an error, okay? You see, function not found or whatever, okay? I didn't pay for that. I didn't pay. I'm pretty confident. I'm not 100%. I would say I didn't pay for that. Now, if your query runs and all of a sudden, which often doesn't happen, it's very rare to happen, but if your query starts running and then it throws an error in the middle, probably then you're gonna pay for it. Okay, when it's processing a random row, something happens. This is very rare. Not often happens, but I would say in that case, probably you would pay for that query.
Can I ask
But
Roger?
I want to say that I
Yeah, go
run
ahead.
probably tens of queries per day. That's what I like. This is the environment I see most of the hours in office, and I never go over like a few, like $50-$70 per month. This is like max. So I'm
Yes.
not caring too much on the cost of every specific query that I run.
Yeah, that was the next question I had. You know, what's the amount you pay on average per month? So you say
If you go select all on OpenAlex, and that's a terabyte and a half, you're going to pay like $8. But if you're just choosing the variables that you care about, it's not a lot.
Yeah, clear. Thanks.
Thank you, Stefano. So we have 5 more minutes, or we can finish, or I can stay for 5 more minutes, then I have to hop off. But if someone has questions, I'm happy to address them.
Can I ask a question? This is great, by the way. So, thank you very much for doing this. This is really great.
Awesome.
In terms of replicability, like dealing with an AEA data editor or something like that, are they familiar with all this, or like how should we think about that?
That's a great question. I can give you my thoughts, then Dror can jump in also. So that's a great question. Replicability with BigQuery is not straightforward, okay? I don't think people is very familiar at this point, as you said, with all these procedures. And second is also like BigQuery is not great. Let's put it another way. You have to be a real expert to know how to manage all the code in a nice way in BigQuery. So like there is no Git integration, for example. It's very difficult to integrate with Git on BigQuery. They have their own solution, which is an SQL-oriented solution, which is for large firms, right? That really like launch products online. And so managing code is complicated. Therefore, what do I do for reproduction is essentially I open a log and I'm very careful myself with all the steps that I do. I store these files, and this will sound like crazy, but manually I copy paste my queries into a Git repo, okay? And I do that manually. So I store my queries in here. And once I have these queries and I say, okay, this query is very important, I paste this into my main file, SQL file on GitHub repo, and then I make sure that I can reproduce everything from start to end. I make sure about that. But it's not straightforward, Bhavin. It's not a satisfactory question. It's a very good question. Do you have anything to add, Dror? It's not ready, okay? It's not ready for like researchers like us to streamline how to make sure everything is reproducible. But
So
Dror,
I discovered this a couple days ago. There is a tool that's called DBT. It's a third party application that I'm learning now that basically solves this problem. And I think this is a great point to kind of end, because I hope to have a discussion about that tool maybe in a future meeting that's going to look at more advanced things. So first of all, thank you all for participating. I hope this was useful, and a huge thank you to Roger for all the work that went into preparing this meeting. I learned some stuff as well. So yeah, thank you. And if Matt, you want to add anything, then.
I just want to say huge thanks to Roger, to Dror, to everyone who joined today. I learned a ton, and thank you all for being here. And hopefully this will help us all be more productive and less time spinning our wheels and getting more stuff published faster. So
And
thanks, everybody.
please sign up to our Google group so that we
Oh,
are
thank
able to communicate with y'all. One thing that is important, we can't see who uses the data. We can't see what you do with the data on NBRA3. So we need a way to tell about updates and stuff. That's going to happen on the Google group.
Just posted it there. All right. Thanks,
Thanks,
everybody.
everybody. Thank you very much.
Have a great
Thank you.
weekend.
Thank
You
you.
too.
Bye.
Bye, bye, bye.
Ciao.